Today, we're diving into some truly thrilling updates from the world of space exploration. Let's start with SpaceX, which is currently hard at work on a massive new project. At the same time, NASA is experimenting with something really interesting: a protective force field on the moon. On another front, Sierra is busy testing a new space drop pod, and we're also saying goodbye to the iconic Delta IV Heavy rocket. Elon Musk recently took some time during a regular motivational talk with SpaceX employees to share some exciting news about the future of the Starship project. Alongside further developments with their Super Heavy rocket prototypes, Musk shared a bold vision for the future, aiming to set up a life for humanity across multiple planets. Though today's discussion is based on a relatively simple infographic, it's packed with complex details that suggest there's a lot more going on than what's just been said out loud. We're watching the planned expansion of the already massive Starship into two new versions, each designed to carry more payload. This increase in payload capacity naturally means more thrust, more fuel, and bigger overall dimensions. Let's delve deeper and find out more about these fascinating advancements. Okay, so version 2 of the Starship introduces some subtle but important tweaks compared to the current model. It's a bit taller, with the booster stretched by about 1 meter and the upper stage extended by 2 meters. These additional 2 meters in the ship stage significantly increase the propellant load, which boosts the thrust from 1,250 tons to 1,600 tons. This boost is key for lifting the overall payload capacity to more than 100 tons for missions to low Earth orbit. Besides these numerical improvements, you can also see some clear visual changes in the design, which seem to be quite intentional. Starting from the top, the nose cone is now sharper and has a more pronounced taper, likely highlighted by the longer and slimmer wing flaps. You can notice a similar change at the bottom of the ship, where the wing flaps now extend a bit further and the heat shield tiles cover a greater part of the hull. Moreover, the interstage has been completely overhauled, providing much more room for ventilation, which is essential during the intense stage separation. This new layout echoes the design of Soviet-style interstage connections, reminiscent of the old N-1 rocket. We also see that the booster grid fins have been moved lower and farther from the interstage, probably to reduce damage from the fierce heat during stage separation, improving booster control during re-entry. At the bottom of the Super Heavy, it's clear that SpaceX has decided to remove the outer shield that used to protect the Raptor engines, embracing a simpler design approach, summed up as the best part is no part. Version 2 really sets the benchmark for what a fully completed Starship could look like, with a focus on efficiency and improved performance. In contrast, version 3 of Starship looks to be a giant leap forward. Elon Musk mentioned in his presentation that V3 will stand at 150 meters, towering over the current launch tower at Starbase. Almost amusingly, the V3 stretches nearly 20 meters taller than V1, a decision influenced by significant functional improvements. Starship 3 is engineered to carry nearly twice the propellant of the existing prototypes. Marking a major departure from V2, SpaceX intends to increase the number of vacuum engines from 3 to 6 in V3. This change will boost the thrust of the ship stage to an astounding 2,700 tons of force, more than doubling the capability of the current model. This enables a remarkable ability to carry over 2,200 metric tons to low Earth orbit. Additionally, with the potential for orbital refilling, these 200 tons can be transported further to the Moon and even Mars. Despite these bold and ambitious plans, SpaceX is facing a long and challenging road to perfecting this gigantic version of its Starship. Recent test flights of the V1 prototype have not yet managed to nail a controlled descent, and the company is busily building more test models for a very active year ahead. These ongoing efforts are part of a strategy to ensure the current version is ready for use in time for the Artemis 3 moon landing, which is scheduled to take place in 2026. Furthermore, the launch infrastructure required for V3 will need considerable upgrades. A taller launch tower will certainly be necessary, and given the nearly 3,000 extra tons of force at liftoff, there are still some doubts about whether the newly installed deluge system on the orbital launch mount will be able to prevent potential damage to the Boca Chica coast. Elon Musk has emphasized that the key motivation for developing new types of Starship, besides achieving incredible power, is to keep pushing down the cost per vehicle. Musk has pointed out that the team is aiming for an estimated $2 million per launch for a fully reusable Starship V3, which is dramatically lower than the current $67 million price tag for launching a Falcon 9. While it might be a bit early to get overly excited about Starship V3, especially before V2 has been completed or the prototype has successfully landed, the idea of scaling up so impressively while significantly reducing the relative costs is certainly exciting. Lunar missions face numerous hazards, even before reaching the moon's surface. But one major challenge that NASA must address is lunar dust. This dust consists predominantly of glassy silicates. With no oxygen or water to erode these particles, they remain sharp and abrasive, much like coarse, unrefined sand. Complicating matters further, this dust is electrostatically charged, making it cling stubbornly to surfaces and intensifying the potential for damage. It infiltrates everything, from gas seals to hatches, and can even lead to discomfort for astronauts, as evidenced by reports of lunar hay fever from Apollo astronauts, a term coined after they experienced allergy-like symptoms from the dust-coated suits. Subsequent studies have indicated that inhaling moon dust could pose serious respiratory issues. In response to these concerns, and with an eye on the impending Artemis missions, NASA revisited an old concept, the electric curtain. Originally conceived in 1967, this idea involved using an opposing electrical charge to repel the dust particles, a method deemed safer than mechanical brushing or vacuuming. Although it never materialized during the Apollo missions, since 2004, NASA has been refining a modern iteration known as the Electrodynamic Dust Shield, EDS. This system, which employs a series of transparent electrodes, generates a mild electric field capable of repelling moon dust from virtually any surface, including spacesuits, solar panels, thermal radiators, and camera lenses. Testing of the EDS began in 2019, with the system installed on 12 test panels made from various materials, including modern spacesuit fabric. The technology even made it to the moon aboard Intuitive Machines' Odysseus lander in February. Although the lander tipped over upon landing, it managed to transmit valuable data from several functional experiments, including those using the EDS-equipped camera lenses. Looking ahead, NASA has scheduled an EDS tech demo to land on the moon later this year as part of their CLPS initiative run by Firefly Aerospace. The persistence of moon dust underscores its potential to disrupt equipment and affect astronaut health, underscoring the importance of operationalizing technologies like the EDS. as plans to establish a functional lunar base or any settlement in a dust-laden, atmosphere-free environment progress, deploying solutions like the EDS becomes increasingly crucial. It marked the end to an important chapter in space exploration as the United Launch Alliance bid farewell to their Delta IV rocket. On Tuesday, April 9th, the revered heavy-lift spacecraft fired up its engines for one final mission into the cosmos. The mission, known as NR-70, was notable not only for carrying a classified payload for the National Reconnaissance Office, likely an observation satellite, but also for signifying the end of the Delta family of rockets. The Delta IV, which has been in service since 2002, has seen various configurations throughout its operational life. Initially, it predominantly served the U.S. Air Force, but over time, it expanded to support non-military and commercial missions, especially after the United Launch Alliance took over its management from Boeing in 2006. Constructed with 3 common booster core segments and a 5-meter diameter upper stage, the Delta IV Heavy maximized the 826 kN maximum thrust of its strongest medium variant up to 3140 kN. Throughout its lifetime, the Delta IV Heavy executed a total of 16 missions, with one experiencing a partial failure. The retirement of the Delta IV has been planned for some time as ULA has been developing the new Vulcan Heavy rocket, designed to replace the aging Delta IV system. After 22 years of service, a remarkable duration for any vehicle, particularly given the rapid advancements in rocket technology over the past 2 decades, it was deemed the appropriate time for the Delta line to conclude its service and gracefully make way for newer technologies. It sounds like a scenario out of a first-person shooter game, but Sierra Space has unveiled plans for a new cargo delivery system capable of dispatching critical supplies to battlefields and disaster zones worldwide within 90 minutes. Dubbed Ghost, this system is designed for rapid deployment of pre-packaged supplies to extremely remote locations. Sierra Space aims to stockpile a vast array of these sealed pods in low Earth orbit, ready to be filled with disaster relief items, medical supplies, emergency food, and even weapons and equipment. Upon activation, the system selects the nearest pod and initiates the descent process. An umbrella-like fabric heat shield safeguards the payload as a deceleration device slows its orbit. Remarkably, the entire apparatus is designed to land within 100 yards of its intended coordinates. This project has moved beyond the conceptual stage. Sierra Space successfully carried out its initial drop tests last month. These tests included dropping a payload capsule from 2,000 feet to assess its durability and descent behavior, followed by a standard parachute deployment at 4,000 feet, and finally, a test where the shield detaches during descent to allow for a different landing profile. The Ghost capsules are built to last 5 years, positioning them as a strategic contingency resource that could meet urgent needs when adequately stocked in orbit. Although Sierra Space, known for their upcoming Dream Chaser spaceplanes, set for testing on the next ULA Vulcan launch, doesn't yet have their own rocket, they are making strides in a niche they can manage effectively. Unlike SpaceX, which has plans to transport larger items like Humvees globally, Sierra Space focuses on delivering smaller, crucial items quickly to any location, with or without traditional landing facilities. The initiative shows Sierra's typical ingenuity and their ability to fill a unique market need promptly. For similar content, don't forget to check out some of the other videos on your screen. If you liked what you saw, you can show your support by subscribing to the channel and staying updated with the latest news.